At the heart of the Milky Way, where stars circle in eternal darkness, lies a mystery that could one day shake the universe. Astronomers have recently discovered a unique binary system consisting of two white dwarfs, the compact remnants of stars that have long since exhausted their fuel but still retain the potential for a major catastrophe. Located at a distance that seems insignificant in the cosmos, only 1/60th the distance from the Earth to the Sun, these two objects orbit each other at an astonishing speed, completing a full rotation every 14 hours. But this is only the beginning of the story. Over time, they will become faster and faster, and their orbits will become ever closer. At some point, when their rotation period is reduced to a mere 30 to 40 seconds, these two dwarfs will inevitably collide. In 23 billion years, they will merge into a single object, producing a Type Ia supernova, explosion of the brightest and most powerful flares in the universe. This explosion will shine with such force that its brightness will exceed the light of a full moon by tens of times, momentarily darkening everything around and leaving its mark on cosmic history. The first confirmed example in our galaxy that could end in such a grand finale. Its total mass, 1.56 times that of the Sun, makes it an ideal candidate for a Type Ia supernova. Such explosions are not only spectacular, but also critically important for science. Supernovae of this type serve as cosmic beacons because their brightness is always almost the same, allowing astronomers to use them to measure distances in the universe. This allows scientists to study the expansion of space, dark energy, and the evolution of galaxies. The discovery of such a system in the Milky Way is a real treasure, as it allows to observe a process that usually unfolds over distances of millions of light years. "It's an incredible find," said James Monday, the study's lead author. "It gives us a unique opportunity to understand how stars evolve before they come to a grand finale." His words reflect the scientific community's excitement that this binary system is not just a pair of white dwarfs, but a living laboratory experiment unfolding before our eyes. White dwarfs are what remain of stars like our Sun after they shed their outer layers and exhaust their nuclear fuel. They are incredibly dense, with a mass similar to the Sun compressed to the size of the Earth. As the two dwarfs orbit each other, they gradually lose energy through gravitational waves ripples in the fabric of space-time predicted by Einstein. It is these waves that are forcing them closer together, bringing the inevitable moment of collision closer. This event, although it will happen billions of years from now, is already giving scientists a glimpse into the future and the mysteries of cosmic catastrophes. The Type Ia supernova that will be born from this merger will not only light up the sky, but also scatter into space heavy elements, iron, nickel, carbon, which are the building blocks for new stars and planets. Everything around us, including the atoms in our bodies, was once created in the crucible of such explosions. So this system reminds us that we are part of a great cosmic cycle where the birth and death of stars are intertwined in the endless history of the universe. But what makes this discovery so special? First, it is its proximity to us on a cosmic scale. These white dwarfs are practically our neighbors. Second, it is the first time that a system has been found in the Milky Way that meets all the criteria for the formation of a Type Ia supernova. Most of these events are observed in distant galaxies, where details are difficult to see even with the most powerful telescopes. Here we can study the system up close, tracking its evolution in real time. Of course, 23 billion years is a time that is difficult for the human mind to comprehend. For comparison, the universe itself is only about 13.8 billion years old. So this explosion will occur at an era when our galaxy may look completely different, and the Sun will have long since faded away, leaving behind its own white dwarf. But for science, time is no obstacle. Already today, this system helps us test theories about gravity, stellar evolution, and the nature of supernovae. For example, scientists can study how white dwarfs accumulate mass before exploding, as this is the key to understanding the mechanism of Type Ia supernovae. There is a hypothesis that such explosions occur when one of the dwarfs steals matter from another until it reaches a critical mass about 1.4 solar masses. In our case, the total mass of the system already exceeds this threshold, making the explosion inevitable. How often can such events occur in our galaxy? Type Ia supernovae are relatively rare. They occur about once every few centuries in the Milky Way. but each one leaves a trace that we can study. For example, supernova remnants like the Crab Nebula are evidence of such catastrophes in the past. The discovery of a new system headed for an explosion gives us hope that we can predict other similar events, perhaps even in our immediate cosmic neighborhood. For astronomers, this pair of white dwarfs is more than just a sight to behold. It reminds us that the universe is a place where every star we see in the night sky has a beginning and an end, some of which end in explosions that change everything around them. This system, hidden in the heart of the galaxy, is just one example of that. And while we won't see this explosion with our own eyes, the very thought of it makes us feel like we're part of something much bigger than we can imagine.